మెయిన్స్ 2020లో అడిగినటువంటి థర్మోడైనమిక్స్ చాప్టర్ నుంచి 7th జాన్ షిఫ్ట్ 1లో అడిగినటువంటి ప్రశ్నకి సమాధానం ఇప్పుడు చూస్తున్నాం మనం. సో హియర్ 2 moles of an ideal gas Cp/Cv is equal 5/3 are mixed with 3 moles of another ideal gas with Cp/Cv is equal 4/3. The value of Cp/Cv is, so here options are there A, B, C, D. So the options are very closer to each other, so hence we have to solve very carefully solution. So here the given data it is where 2 moles of an ideal gas with mixed with 3 moles of another ideal gas. So the number of moles is here N1 is equal to 2 moles and N2 is equal to 3 moles. So here the direct formula it is gamma is equal or Cp/Cv is equal to N1 Cp1 plus N2 Cp2 by N1 Cv1 plus N2 Cv2. So here N1, N2 are known values, Cp1, Cp2 and Cv1, Cv2 are we have to determine. So from case 1, so let us take in from given data Cp/Cv is equal to 5/3. The relation between Cp and Cv here Cp minus Cv is equal to R, whereas Cp can be written as R plus Cv. So here from this we can write Cp is equal to 5/3 into Cv. So 5/3 into Cv is equal to R plus Cv. Just you have to solve it. 5Cv it is equal to 3R plus 3Cv, where simplify that 2Cv is equal to 3R, where Cv is equal to 3R by 2. So this is equation 1, let it be Cv1. So from this we can write Cp1 also, where Cp is equal to R plus Cv, it is R plus Cv1. So here R plus Cv1 nothing but 3R by 2. From this we can write 5R by 2. So it is Cp1. So this is equation 2. Similarly, case 2, from given data Cp/Cv is equal to 4/3. We have to determine as well as Cp minus Cv is equal to R. Cp is equal to R plus Cv, whereas Cp is written as 4/3 into Cv. 4/3 into Cv is equal to R plus Cv. We have to simplify that, where it is 4Cv is equal to 3R plus 3Cv. It is Cv is equal to 3R. So this can be equation 3, where it is Cv1. And similarly Cp is equal to R plus Cv1. So here R plus Cv1 nothing but 3R. It is equal to 4R. So this is Cp. This is Cp2. This is equation 4. From these values we can substitute in this equation. We can get the answer. So that is where gamma is equal to N1 into Cp1 plus N2 into Cp2 by N1 into Cv1 plus N2 into Cv2. So N1 it is equal to 2 into Cp1 nothing but 5R by 2, and plus N2 is equal to 3 into Cp2 is nothing but 4R by N1 2 into Cv1. Cv1 is nothing but, so 3R by 2 plus 3 into Cv2. Cv2 is equal to 3R. So just cancel out 2 and 2. It is 5R plus 12R. It is equal to 17R by 3R plus 9R. It is 12R. R will be cancelled out. It is 17 by 12. It is equal to 1.42. So here the option it is 1 option it is C. 7th John shift 2 JEE Mains 2020 from Thermodynamics. Under the adiabatic process, the volume of an ideal gas gets doubled. Consequently, the mean collision time between the gas molecules changes from tau 1 to tau 2. If Cp by Cv is equal to gamma for this gas, then the good estimate for tau 2 by tau 1 is given by option A, B, C, D. Actually, this question was very challenging question. So many viewers are sent challenging to the NTA, and this was given by bonus question for all students. So there is no option, right option given by NTA. So how can we solve this? So solution. So here the relaxation time will be given. So tau it is equal to relaxation time. Tau inverse is inversely proportional to the absolute temperature. So with volume it is V inversely proportional root T. It can be also written as tau inversely proportional V by T power 1 by 2. So here for an adiabatic process, the relation between temperature and volume T proportional 1 by V power gamma minus 1 for adiabatic process. So here we have to understand, under the adiabatic process, the volume of an ideal gas gets doubled. So here the initial volume V1 is equal to V and the final volume V2 is equal to 2V. So this is the concept. So here from these two equations we can write that, so tau proportional to the V into V power gamma minus 1 by 2. So here, whereas 1 by 2 will be written as, so tau inversely proportional to V into 1 plus gamma minus 1 by 2. So here tau proportional V into gamma plus 1 by 2. So here from this we can write tau 1 V1 power gamma plus 1 by 2 and tau 2 V2 power gamma plus 1 by 2. So as well as given that tau 2 by tau 1 is equal to V2 by V1 whole power gamma plus 1 by 2. So V2 it is equal to V and V1 is equal to V. So whereas gamma plus 1 by 2. So VV will be cancelled. So hence tau 2 by tau 1 is equal to 2 power gamma plus 1 by 2. So this is the answer, but here there is no option. So that's why this is the challenging question, and they can give bonus marks for all the students. Thank you. Similarly, 8th day shift 1 from thermodynamics, a Carnot engine having an efficiency 1 by 10 is being used as refrigerator. If the work done on the refrigerator is 10 joule, then amount of heat absorbed from the reservoir at lower temperature is, so option A 99 joule, B 90, C 1 joule, D 100 joule. How we can solve for this answer? Solution. So in a Carnot engine, the basic rule it is Q1 is the heat rejected by the reservoir at high temperature. Q2 is the heat absorbed at low temperature by the reservoir. So here the work done in a refrigerator, W it is equal Q1 minus Q2. Q1 minus Q2. Work done W is equal Q1 minus Q2. So here efficiency in eta is equal 1 minus T2 by T1. 1 minus T2 by T1. So already given that eta is equal to 1 by 10. So here from this we can write where W is equal to Q2 q1 by q2 minus 1. So keep it as equation 1, and from we can write where neta for 1 by 10 is equal to 1 minus T2 by T1, where T2 by T1 is equal to 1 minus 1 by 10 is equal to 9 by 10. So T2 by T1 or Q2 by Q1 is equal to 9 by 10. But we have to find out the value of Q2. So therefore W it is equal Q2 into Q1 by Q2 minus 1. So it is W already given the 10 joules. Q2 into Q1 by Q2. So here Q2 by Q1 is equal 9 by 10, where it is reciprocal Q1 by Q2. It is 10 by 9 minus 1. So here Q2 into it is 1 by 9, where Q2 is equal 9 into 10, it is 90 joule. So the answer it is 90 joule. Thank you.